Today we will be presenting our senior capstone project through this research poster. So for a brief introduction, we identified a common healthcare problem called catheter-associated urinary tract infections, or CAUTIs for short. CAUTIs affect a large number of people every year and increase the cost of healthcare associated with each hospitalization. That's why our aim is to redesign catheter tubing to incorporate valves within. That way, the backflow of urine, which is one cause of CAUTIs, can be mechanically obstructed. While mitigation of backflow is our primary aim, some other user needs include size specifications, transparency of tubing, and unobstruction of outflow. Some of these necessary considerations have been established previously by the FDA and will be validated by testing our device. Figure 2 shows these valves on our initial 3D model for better visualization of our primary goal. Note that this is a bicuspid valve structure and is subject to change as we progress with flow rate testing. The focus of our research so far has been on creating molds in Fusion 360 to injection mold our valve tubing. Our molds will be 3D printed using PLA filament and injected with a silicone material. Figure 3 shows our first prototype mold, in which tubing will be molded in two halves and then sutured together. The top piece of the mold is shown in wireframe for better visualization of the valve cutouts underneath. Figure 4 shows the second iteration prototype mold, which molds tubing in one complete piece with no suturing needed. This produced our first viable prototype tubing in Figure 7. Figure 5 shows the third iteration of the prototype mold. This allows easier extraction of the tubing from the mold and is currently 3D printing. Some initial testing of our device includes clarity testing and size specifications. For clarity testing, we used a silicone disc from our early molding process and placed it against different colored backgrounds. In Figure 6, you can see this disc against a yellow background demonstrating transparency. Our current diameter of tubing is 19.96 millimeters, which is above the current acceptance range specified by the FDA. However, subsequent molds are decreasing in diameter as we refine our process. Future work includes flow rate testing in both backwards and forwards directions and manufacturing of longer, narrower sections of tubing to meet the specified FDA guidelines. Thank you for your time.